B. Figure 10.1 shows a loose wire connected in a circuit with a DC direct current power supply and a switch. The length of the wire between the two supports in the magnetic field of a horseshoe magnet. The power supply is switched on and the wire moves down. So the direction of the wire is moving downwards. These are the two supports, the wire in between, and this is the horseshoe magnet right here. And then we have the DC power supply. So part 1 says, on figure 10.1, draw an arrow on the wire to show the direction of the current. So the direction of the current would be determined using the Fleming's left-hand rule as DC power supply is given. When there's a DC power supply given, that means that we're supplying current, so current is not being induced. If current wasn't being induced, we'd use our right hand. Right now, we're going to use our left hand and make our fingers perpendicular to each other. Point our thumb downward and the index finger into the page, and the second finger shows the direction of the current, which is from right to left. Here's a picture on the side to give you an idea. Part 2. The power supply is switched off and the wire returns to its original position. The power supply is then switched on so that the current in the wire is in the opposite direction. State and explain what happens to the wire. The wire moves upwards as the current is reversed, so by the Fleming's left-hand rule, the force on the wire is opposite. You can even use your hands. You'll use your left hand, your index finger like the magnet, so you can see that if the current is going from left to right, okay, middle finger from left to right, index finger into the page, your thumb will point up.